Ladies and gentlemen, welcome back to another live stream. So, in today's live stream, we're gonna try to create a 3D graphing calculator in Bevy. So this is not scripted. It's not like a tutorial where I'm gonna exactly show you how the heck we're gonna do this. We're actually gonna try this together in stream. It's scripted. I don't think I've done this before, but yeah, we'll see how it goes. So I'm doing this to actually learn more about Bevy, and also I would like to hopefully make some useful product. Hopefully. We'll see how it goes. So let me just share my stream. Please join my Discord server. You can find the link in the description so you get notified of new streams. Alright, let's go. Okay, let's grab our chat. Hello, Loop Luminary. Welcome back to the live stream. Welcome back. I think this is the third live stream that you have came in as first. Maybe, if not the fourth, I'm not sure. Anyways, alright, so I already have set up this stuff, so we don't wait here 30 minutes just to compile Bevy and all its dependencies. So to actually fix that, so we don't like to avoid that, I actually made a template. So Codotaku Bevy template, here's the link in the chat. So you're just gonna go ahead, you're gonna use this template and create a new repository, right? And then you can call your repo whichever you want. In my case, I called it Codotaku graphing calculator, right? And then you could just create your repository, and then you can clone it into your IDE. And there you go, boom, you have all of that initial setup ready. Perfect. So the only things that I've added is these dependencies. But let's see. Okay, so by default, that template, what I included is just Bevy inspector EGY. So Bevy with dynamic linking for faster build like compile times, and Bevy inspector EGY, Bevy EGY. And for this specific project, I added these two dependencies, Bevy pen orbit camera. There's no need, absolutely no need to reinvent the camera for no reason. There is a pretty good plugin out there. And now for expression evaluation, we're gonna use eval XPR. I've never used eval XPR before, so this is gonna be my first time, so we'll see how to use it. I don't think it's gonna be that hard, so hopefully it works as expected. Alright, and the other stuff is just for, you know, optimizing Bevy and so on, whatever. Alright, so, and of course I changed the name here, and that's pretty much it, I think, what I changed so far. And yeah, for main RS, I just set up those plugins. I set up the pen orbit camera plugin, and then I added the pen orbit camera component to my camera, and there we go. And that's basically what I've done. And now let's just say cargo R, and you basically get the Bevy template 3D scene with a pen orbit camera that you can move around by clicking the mouse and dragging. And also you can zoom in, and everything is super freaking smooth. And you get this world inspector, which you can actually use it to debug. You can see everything that is here, all the components, all the entities, etc., etc., all the resources, all the assets, and you can even change them, like clear color. There you go. You see what I mean? All right, cool. So let's get started, I guess. And where the heck we're gonna get started? I don't know. Well, I guess let's get started by removing first of all the circular base and instead making like a flat plane, right? Which gonna represent our graph, okay? And I don't think we're gonna need this cube right here. And for the circular base, we're not gonna need a circle mesh anymore, nor a cube mesh actually. So let's remove both of these. For light blue material, I guess we could keep that for now. Maybe we'll see how it goes. Alright, so we're gonna need a plane mesh, and to be exact, not any plane mesh, but we're gonna actually need, well, let's call this graph mesh really, and mesh.add, and not any specific, like not any regular plane mesh. We're gonna need some planar or plane mesh with subdivisions. And how we're gonna do that, so we could actually change each vertex separately, because otherwise we're gonna only have 4 vertices in the plane, which is not enough to represent our graph. So how we're gonna do this, we'll see. Plane 3D builder. So there's this plane 3D builder, and that you could actually create. I'm gonna go with that. Is there like a new function or something, or maybe segment length? No. How the heck do you do this? Plane 3D builder. Do I seriously have to give it all of that? There should be some way to create like a default thing or whichever, like a new function. That's strange actually. Hold on, let me go to the documentation real quick. So Bevy plane 3D builder. Documentation please. Oh my god. Plane 3. Well, let's make sure. I'm actually not using 0.14.2 by the way. I'm using 0.14.0 because all the other plugins are using this version, not the latest, because well, they can't keep up. So yeah. Alright, so let me make sure that I am in that version. And then let's search for plane 3D builder here, and let's see what we got here now. Is there a default implementation? Doesn't seem like it. Is there a new function? Well, no. So I guess then I have to do it myself. Alright, fine. It's okay. So can I do it this way? And then I maybe .build or what? There's no build function either, apparently. So plane 3D builder, missing structure fields. Let's fill these struct fields and let's see what we got here. So we got gizmos. Hold on. Config. Why the heck these are private? What? Okay, how am I supposed to... What? I'm very confused right now. Let's search up for some example about this. Bevy. What? Let's try to find an example that uses it. What the heck? Are you kidding me right now? Okay. Let's search here. And let's see. What? No one is using it? Are you kidding me? I'm pretty sure I've used this before, but now I cannot use it apparently. So these aren't public. These need mutable self. What the heck? There's no static functions? Bro. What? Absolutely incredible. Oh, maybe, well, hold on. Nope, 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 nope. Ridiculous. So maybe something is actually creating it. I don't really see it. Okay, I guess this is the actual one. Oh my god. So we're using the wrong one apparently. It's called Plane Mesh Builder. So I'm not sure what the heck is that Plane 3D builder. Maybe it's an internal struct? I have no clue. Anyways, so this is the actual one that we want. I was like, what the heck is going on here, dude? Oh boy. That alone, how much time it costed me? Man, 10 minutes. Crazy. Okay, let's see what this got. So you got a new function. Yeah, we can say from length right here. So from length, I believe. And let's import this, I guess. There we go. Now from length, and let's give it 1.0 for now, I think. And does this work? I think I could probably just do it directly here. I guess, let's see. Oh yeah. Now let's actually try to use this. So instead of circular base, this is gonna be our graph. Our graph object, I guess, or I don't know what you call it. Let's just call it graph, fine. And let's give it this graph mesh, and it's gonna have, I guess, that white material. And yeah, we don't need this light blue, I guess. And yeah, that's probably it. Let's try this out. We should have a plane right now, and for whatever reason we don't. Oh, we actually do, but it's not in the right direction though, apparently. It should be facing upwards. So how do we do that? So from length with the normal pointing upwards, but it's not. What the heck? That's crazy. From length, default. Bro. Never mind. Let's just construct it ourselves. That's strange. Fill the struct fields, and here let's go with plane 3D. And what's other constructors there's here? Maybe new. So here we got the normal, which is basically vec3, probably y. There we go. And the half size would be let's say vec2 splat 0.5. So we could make like a plane that is 1 by 1. And now the subdivisions. This is the important one. If you say just 0, this is like creating a normal plane 3D. But let's just start there. What? Are you kidding me? Okay, hold on a second. PBR mesh. Transform. Oh, my bad. I see. I forgot. I actually have from rotation here in the transform. Oh boy. Let's just remove this crap, please. I was blaming Bevy for no reason. Oh my god. Alright, never mind. Let's see what we got. So now we could actually use, yeah, we could use that from length thing here, I guess. So 1.0, and there we go. So this should work now. The camera, is it facing down? It's facing normally. Okay, so this is what I want. This is perfect. Okay, perfect. So we got right now a plane that is 1.0. How do you actually make it like, what is it called? That kind of rendering, like where you actually see the geometry. Wire mesh, I think. Wireframe, yeah, wireframe. Bevy wireframe rendering. How do you actually do that? Let's see. Default plugins. Need to add this plugin to enable wireframe rendering. Okay. With this resource. Let's try it. Let's add that plugin and see. Would that work? Import it and let's go. We got the plane, it's literally the floor. It's not the floor, it's going to be the graph. This is the one that we're going to shape to make the graph. So it's still not wireframe. Let's see why. Okay, maybe we just gotta add this wireframe component then to our graph. Oops, not here. Let's add it like this. And let's run this. Okay, we gotta import this. And let's try to run this. I just wanna see the wireframe so I can show you what I mean. Alright, perfect. This is what I want. So you see right now the plane that we got, it only have, you should add a muscle component so you can put yourself in it. So we got just four vertices and only 2 triangles. So we can't really do much with that. So let's add some subdivisions. So how are we gonna do that? Can I actually change that? No, I can't apparently, which sucks. So I guess maybe I have to use new then. Well, not even new. Yeah, I just have to freaking do it the normal way then. Alright, fuck. Plane 3D. I thought it was a builder, but apparently it's not. Vec3y, and then the half size would be Vec3 splat 0.5. Oopsie, 0.5. And the subdivisions, let's say, for example, 10 subdivisions. That's probably not enough though. Oh, okay. I guess like that. And the normal should be Vec3. What? Expected dir 3. Oh, okay. Why? Alright, there we go. Now we have 10 subdivisions. Now I could actually transform, hopefully, these vertices however we want. Now we need to figure out how to do that. Good question. We have to figure out how to actually edit the mesh. Well, to edit the mesh, we probably first of all have to grab the mesh outside of the handle here, because that's just the handle. And let's see if we can actually iterate through this or something. Well, maybe I have to build it first. So build. And now can I actually, let's say, iterate through the vertices or something? Yeah, how do you change the vertices? Compute, generate tangent. There is a get vertex buffer thing, but I'm not sure if that's exactly what we really want here. How to edit Bevy mesh vertices. Manipulating mesh vertices. Why are you using a mesh to plot? There's a lot of overhead. The person of watch, welcome to the live stream. What do you suggest to use instead? Because that's just the idea that I got. What do you suggest to use instead? It's gonna be a 3D plot though. So we have this stuff for the vertex buffers. So passing domain values to the function. Domain values to the function? What do you mean? Get vertex buffer. Okay, so get vertex buffer date. Oops. So is this mutable or? It's a vec of u8, but it's self. So I guess it's actually immutable apparently. So that kind of sucks. Therefore, the attributes are located in order of their. All right. So this is our vertices, apparently. And now let's actually go through them. Vertices, or let's just say for vertex. In vertices, iter. Actually, we're gonna go with iter mute. We're gonna change that stuff. And let's go. Let's just make sure this works first of all real quick. Alright, perfect. Perfect. Now, oh, actually these are bytes. These are individual bytes. Oh boy. Oh boy, oh boy. It is 3D, then you have function that would return R3. Yes, yes, but we need somehow to actually display it to the user, you know. Like, we can only use a mesh to display it to the user. We're not really into the math just yet. Right now, I'm just kind of like making a height map. So we could actually change each vertex height depending on the function's, you know, y value, basically. So, yeah, I need to figure out right now how do I... Well, how can I... Do I use bytemock here or something? Like, maybe bytemock cast? I really need to create a plugin to have logs displayed to the user. No, it's just gonna be displayed. Hold on a second. I just need to figure out the way that Bevy... How can I manually create meshes in Bevy with vertices? Well, I want to edit a mesh. You know what? Let's just try to do it myself. Fine. Let's use bytemock here. Cast slice. Do they have like a vertex type? I would guess so. Then I would convert it back. Now I don't think we have bytemock imported, which sucks. Because right now we have to wait for it to compile. Right? And so... But hold on, let's not actually do this here, I think. Oops. Though I don't think cast slice would work in this case because this is a vector. Hold on, the analyzer is still working. But one generic argument, yeah, so all right, let me just grab this. Let's see what cast functions I have. Okay, I have a cast Vic, so that's great. And hopefully I could take this, put it here. And what the heck is happening here? Let's see, cast Vic function takes 2 generic arguments, but 1 generic argument supplied. So Vic A, Vic B. Oh, so maybe I do it like this. That's strange, but whatever. All right, let's see if this actually works. Let's see if this actually works. When Bevy or any program that makes a mesh is doing a lot of background math, when you use the mesh, you're essentially using surface to plot a surface. Yeah, true, but like I can't think of another way. Okay, hold on. Alignment mismatch. Hold on. So basically what I'm trying to do here is like an immediate mesh. So Bevy immediate mesh. So because we're gonna be changing the vertices every frame. Let's go to Bevy mesh docs. Bevy mesh docs. Mesh. With inserted attributes. Or you know what? I could snatch the Bevy. Isn't there more primitive type? Like, can you render an array of vertices and then create them on your own? Yeah, but I just want to like avoid doing that math myself. But you know what? There is a little thing that we could do here. We could check out the thing here. There we go. Okay. So this is how it's done. Right? So I could just grab this code and make it mine. And then edit it however I want. Honestly. So let's say create mesh or whatever. And then we're gonna have something like this. Okay. There we go. Now it's gonna have like subdivisions, or you know what, it's a good opportunity I guess to say maybe struct graph and then store this stuff here where we have like a new function, and then we could have that stuff there. So let's remove this. All right. I would plot singular points in 3D and then attempt to connect them with triangles. I mean, this is exactly the case here. This is exactly the case here. So, self. Right, self.subdivisions. So for subdivisions, yeah, we do want that to be an option. I mean, a configurable. Self.plane.normal. I mean, why not have the normal too configurable? And then, yeah, it's a simple for loop, and then the Bible should be triangle strip instead of list. Let's just go with this for now. Self.half size. Half size. and self.plane.normal, self.normal, and then later on we could optimize it. Okay, perfect. Now fill the struct fields. No. What the heck am I doing? Uh-oh. I forgot that this isn't actually a static function. Oh boy. Da da da. Well, fine. Fine. Let's actually copy these and put them around here in the parameters, and then instead of self, let's remove self from there, and we're good to go. Now hopefully we could, oopsies, fill the struct fields, and we're good to go. Though honestly we don't really have to store them. You know what, we don't have to store them, really. It doesn't matter, I guess. So anyways, so we got the primitive topology and render asset usages. Let's import the other stuff that we're gonna need. And what else? So I guess this is it, maybe? Oopsies. So, and we're gonna return a mesh, which is a triangle list for now, with these indices and stuff. Expected graph found mesh. Oh yeah, well, so this is gonna be basically, well, gonna have a mesh being a mesh for now, maybe. And then we could just like say graph mesh being this stuff right here. And there we go. Perfect. We could try to maybe optimize this further with, let's say, triangle strip, as you said. But for now, this should hopefully work out. Let's see. Now, instead of this, let's just create a new graph where the subdivisions is, I don't know, 10 for now, dir 3, y, and the host size would be a vec2 as plat, for now 0.5. Okay, cool. And what the heck, why self? Bruh. Remove the self from here, and there we go. Alright, that seems about right. Let's remove this stuff that we had here. And basically, we're gonna grab the mesh, self.mesh. Though honestly, instead of that, I'm probably gonna store all of these, like the positions, normals, UVs. Oh, well, this is interesting. Graph dot mesh. The thing is, I'm gonna create, well, I'm not sure if there's like a Bevy way of doing immediate geometry, like geometry that you're supposed to upload or update every frame. Mesh new. There's nothing about that here apparently. So I don't know. We'll just do it the inefficient way for now. So I don't think we want to create the mesh right now. So like, yeah, we don't want that. We want to do it here, really. Right, and then we're gonna have self.indices, hopefully. Self.indices, self.positions, and self.normals, and self.UVs. Okay. Now let's actually add those stuff there. Well, let's just, I guess, copy. No. Let's just do it manually here. So instead of stuff like this always feels easier with Vulkan directly. Never tried with engine. Yeah. Positions would be a vec, normals, UVs, indices, and there we go. There we go. Graph. Fill the struct fields, and let's go. Now basically we're gonna have like, well, what the heck is going on here? Cannot move out of, which is behind a shared reference. Oh, so we're gonna copy anyways? Apparently. Yeah, we're gonna have to copy anyways. But fine, I guess, for now. If anyone knows like a better way in Bevy, let me know. There we go. Now we could have like another function that would take the heights. So update, and it would basically take some expression. Mutable self. Though it would be a compiled expression, I think. So I did add this library called eval expr, which we're going to try to use today. And let's actually check out the documentation of that real quick. Eval expr. Or let's just hard code some expression for now. Really. So here's what we're going to do. So we're going to go through all the vertices. So for vertex in self.positions, .attribute vertex.y equal to vertex.y.sign. Good job. What? No. Let's grab the time here. Let's say t. Well, you're basically gonna get like t. Not really. What the heck? No. What the hell? No. Yeah, something like that. For example, like in function of x and z. Exactly. Yeah, in function of x and z. So for example, that equation. All right, or that expression. Perfect. Yeah, that's pretty good. And now, Walaikum salam Wabjigir, and welcome back to the live stream. So now I'm trying to think how we're gonna do this exactly. We have to update the mesh. But let's just start by just making a simple mesh for now, like just once, not updating it. So meshes.add graph.mesh. So here we're gonna create a new mesh out of that graph. And I think we should be good to go. Maybe. And we're not using this entity here. Okay, let's see how this goes. All right. And what? This is, oh, we're not updating the mesh, my bad. So graph.update. Okay, we gotta make that mutable. Now let's run this out. Now we should have a graph. There we go. That's what I'm talking about. Okay. But, well, it should be double-sided, double-faced. Huh. How we could do that, I wonder. Disable backface calling, but yeah, but how? And okay, let's ask Copas, see if it's any helpful. How to disable backface calling in Bevy? Oh, it's in the material. That makes sense. So we're using the white material, right? Yes, we are. So, okay, cool. Can I maybe change this into a material? But what this actually takes exactly? Impl into a asset, which is probably like a material. Standard material probably, yeah? Or no? Yep, there we go. Now can I set the calling? And then hopefully add the match there. And let's just say this, call mode, and oops, whoops. Discard, please. What the heck? Let's remove that, let's remove that. Let's go down here. Where is it? Here we go. So why this is not what call mode is? Oh, it's option face. It's set to none the two sides of the measure. Okay, cool. That makes all sense. So let's say none. And this should be mutable then. Oops. Mutable. Now let's see. This should fix it. And there we go. Right now we have both sides. And the more we like increase the subdivisions, we could also make it a bit transparent, I think. Is there like a transparency thing? How to change transparency of a material? Alpha mode, blend. Oh, and you use RGBA. Next, get model from Blender. Map.alpha mode is equal to what alpha mode is. Alpha mode makes sense, and it needs to be blend apparently. And what the heck is, oh, semicolon. And then instead of color white, we could snatch that value from here. Or we could just say sRGB maybe. What was the function getting graphed? The function getting graphed is this. So basically x, so y is equal to x times, well, to the power of 2 plus z to the power of 2 square root. Well, square root and sine for whichever reason. It just generated by the AI and it just rolled with it because it's just like something to test with for now. But that actually we would get it from the user soon. So yeah. Okay, where I was here. Okay, so color white. So instead of that, we're gonna go with sRGBA exactly. So red. I would say it's parsing the equation sounds really tough. We're not gonna do it manually. We're gonna use a library for that. Alpha 0.5. Though we probably would like if we want some more advanced stuff like equations, we would probably have to roll our stuff, our own, or at least some of it. Wait, where's the library name? Yeah, I'm gonna come into it, in a second. I never tried it, so we're gonna try in the stream. Cargo R. Alright, so it's a bit transparent now, which is amazing, perfect. We could even add more subdivisions if we want to here. I don't know, let's say maybe 64, maybe that's too much. But basically, oh boy, look at that, that's super smooth. All right, that's pretty cool, lovely. Let's try something else. Let's say, why we have this sqrt here though? What about just sine? All right, so this is a sine wave, x and z, perfect. This is what I'm talking about. Now let's actually use an expression from the user that is going to be a string, of course. So we're going to get a compiled thing, so a compiled eval. So I'm going to try this crate. We could switch out to another crate, but for now let's try this one first. It's called eval expr and it seems to be still maintained. There's another one called fast eval which may have more performance, but apparently it's, oh, hold on, is it the one? Hold on. Oh boy, not this, Rust. Yeah, there's this one, but it's not maintained anymore. I think it does have more performance, but you know, let's just go with the maintained one for now. So, already actually added that library, eval expr. There we go. Now the compiled one is, so we're going to pre-compile the expression because we want to use it in a loop, right? So we don't want to do the parsing for every loop iteration. That's going to suck, right? So here we're going to build operator tree. Let's search this up. Build operator tree. So it takes a string and it gives us back an AST node of the expression. And later on, if we don't like the evaluation, we want to add something else, we could maybe just reuse the AST, but then like do our own evaluation stuff maybe, or whatever we want to do with it. But anyways, so here build eval expression result. So we're going to need this node numeric types, I think. Yeah, pretty much. So expression would be node numeric types, and I don't think we really need, what, hold on, I think we just need a reference to evaluate it, right? Yeah, just a reference. So we could just do this. And what else? So struct takes 0 generic arguments. Huh. Okay. But is it the right node though? Because, oh no, it's not. It's not. Where is this node is being imported? Maybe it's with the prelude or something. Yikes, I'm not sure. But let's actually get it from here. So use eval expr node. And then here, quick fix. Cannot find in the scope. What? Why you cannot find it? But actually I probably could just like do this maybe. Yeah, that's fine. All right, perfect. So now we have our expression, our compiled expression. Now we're gonna need a context. Gonna need to create a context, and context, apparently they're using a hash map context. Let's see if there's like multiple contexts maybe, and see what our, so there's this hash map context. Is there any other types of contexts? Context, empty context. Doesn't really seem like it. There's empty context, but that's, what about this one? Yeah, let's go with this hash map then, hash map context. And then we create a new with no mappings. What about the built-in functions though? Huh. Hold on, how the example actually does it? Because there is an example here. In the main page, they have a context. Oh, they're just using a context map thing here, apparently. Let's see. Yeah, they're using this context map thing here. So, but no, hold on, let me see what this context map macro actually does exactly. Does it just... Can I maybe see the source code? Oh boy. Context with mutable variables. Set value. Hash map. Oh, there we go. Hash map context, yeah. All right, let's go with that. So hash map context. And new. But I'm not sure how I can add the built-in functions though. But we'll see about that later on anyways. So type annotations needed. So this would be mutable, right? And so in every iteration, we're gonna set the value x to the vertex.x, and then we're gonna set the z to vertex.z, and that's basically it. You cannot use y for now because, well, we're using it. It should be sideways if z is height. If z is height, no, y is height in this case. I got to div code. Where is this? All right, so let's see what we got here. I think set. Okay, set value, and here the identifier, which is x, and it's apparently taking a string, which sucks, but whichever. And then here we got a value, which is okay. So does this works? Apparently not. Expected enum eval xpr value. Okay. Can I though see the into? Is there like a from implementation for that? No, apparently not. So then let's just say value. Can I say maybe from? Apparently neither. Okay, then let's go with from float. And I'm not sure why it's doing that. It's F32. Does this really? I mean, I guess it's fine as F32 maybe. Yeah, it is fine. So now the same thing with the z-axis. And there we go. What's up? And here what we're gonna do is expression.eval number with context, I would guess, in wrap. Now what the heck is going on? Expected F32 found F64. All right. Is this enough? What? Good night, Robert. Thank you for tuning in. Expected F32 found F64. What does that even mean? Oh. I see. Thanks. As F32. Alright, so I think that's basically it. Now we have to construct that expression. So though honestly we could get the hash map context from, hold on. So we could say, where's C context numeric types? Like I guess we could say this, right? So instead of constructing the context ourselves every single time, we could get it from the user of this function, or the caller of this function basically. So context reference C, and so we wouldn't need this anymore. And what else? C context numeric types. Well, let's actually just copy this whole thing and let's do where import context from eval xpr context numeric type, same thing, but apparently it doesn't want to give me that for whatever reason, which sucks. Yikes. So maybe that's numeric types is maybe private or something. I would guess so. Maybe it's actually talking about this one instead. It should be F64. I think so. I mean, let me try this though. Hold on. No, it doesn't work. So, alright, let's try F64 then. Like a param. It does seem to work maybe. So, if we do this now, does this work? Honestly, why bother with generics? I'm stupid. Let's just go with hash map context, please. That is wild. Generics are crazy. Just like that, though it needs to be mutable, yeah. And there we go. Perfect. Perfect. Now we could actually create the context here ourselves. Though, could we have it maybe in the graph itself? I think there is no need. I love to see you get to just write the code. Yeah. Should like every graph have its own context or not? Good question. I don't know. Should it have its own context? Maybe not. Well, for now, no. So let's just create our own context here. Are we doing multiple graphs? Yeah, for sure. We're doing multiple graphs. We're just starting with one graph, but we're surely doing multiple. Hash map context new. So the update function, it needs, of course, the expression, which is the actual compiled expression. So there we go. And it needs the context, mutable context. And I think that works just fine, right? Yeah, I think so. All right, let's actually try this sound, find out if it works. And I wonder how is the performance actually. Oopsies. Function identifier not found sign. Yeah, I need to figure out how can I load the built-in functions to this. How do you load the built-in functions? What? Let's see. But I mean, we could do it ourselves, but I do think they do have that. Set built-in functions disabled. That kind of sucks, because like in my brain right now I have a negative of a negative. It should have been better like set built-in functions enabled. Disabled. So do we want to disable them or not? We do not want to disable them, so false. Alright, so let's actually try this now. Oh boy. It's still saying function identifier not found apparently. So what this does exactly, it just changed some. What in the world is that? Well, I have no clue. Maybe let's search up even more on this. Da, da, da. Let's search for math. Or like, no. Math const built in. Okay. Built in. Empty context with built-in functions. But why its own struct context that returns none for each identifier? That's strange. But like if we use this instead, would that work? Fail to resolve, use quick fix, qualify real quick. Default maybe? Oops. Does that work? No. It wants this now. The real question is, can I actually change it then? Yeah, no, this sucks. This really, well, hold on, actually, hold on. Can I set values and give values? Set value? No, I can't. So no, this really sucks. That's strange. So let's just do it ourselves, honestly. Context. Or we could use their, yeah, we could use their macro too. But honestly, I feel like there's no need, at least for now. Let's add the sine and the cosine function. So context set function. Oopsies. Set function. So the identifier would be cosine dot into to turn it into a string. And then here apparently we're gonna need, you know what, let's go to the example please. Oh my god, let's go to the examples. Let's just snatch this please for a second. Though can I still say set hold on, let me see what we got now. Consider importing qualify. Alright, so what we got here, hash map context. Cool. What if I don't have anything? Does this include the actual built-in functions? Huh. Really? Let's just keep them. Okay, fine. In used imports context with use of in declared type eval xpr error. Alrighty. So let's see how we can do this. We don't need any of those, though we do need the... Alright, so let's make our own function here real quick. So basically we want cosine. Oops. Let's add some space here. So function u, argument, and what the heck is going on here? What? This is very strange. Oh. That's very confusing. Oh boy. Control Z, please. Control Z, Control Z, Control Z. Okay, so does this work? Import. Alright, so let me just copy this, please. And a comma here, and let's do this. Now we have a cosine. And here they're saying argument as tuple. In my case, I don't want a tuple, only a value. So argument is equal to argument as number, I would guess. Yeah, perfect. Now what we have here. Okay. What? Argument as number dot cosine. Just say as float, please. Maybe. That doesn't work either. Alright, fine. Let's just do number like this. Let number f64 is equal to this, let's say. Alright, perfect. Perfect. And now let's do the exact same thing for the sine wave, sine function. And instead of cosine, I'm just gonna say sine. There we go. Alright, so we could remove this stuff now, please. Integer. Alright, so I guess that works. But it's not like what we had before, for whichever reason. Well, it's probably a different expression. Yeah, it is. It is a different expression, I see. But that's pretty lovely. That's pretty lovely. We can indeed make multiple graphs now. Too. Like multiply in blend mode would look better. Good question. Let's see. Or should I say good suggested? Well, whatever. Cargo R, let's see. Like it would get darker. I don't know. Not sure. Does it look better? Seems fine to me. Nah. Okay, let's go back to blend. I don't see a difference. I do see a bit of a difference, I think. But I don't know. Anyways. So we're good. Now we actually have to make a UI for the user to actually give the expression and then update the graph as well, depending on that expression, essentially. Now I have to figure out how to do that using EGUI or Bevy UI, though I think Bevy EGUI would be way easier to do this. So let's see how. So I'm using this Bevy Inspector plugin, right? Bevy Inspector EGUI plugin, and I think it does have a way to integrate with it that is probably easier. Let's see. Display a single resource in a window. Resource. I mean, we do want to have multiple graphs, but I guess we could go with that. And otherwise we could go with the manual UI. So like inspector minimum maximum. What about a slider though? That's why I'd rather go with the manual UI, honestly. So you have here EGUI plugin, add plugins, Bevy Inspector EGUI, default inspector, configuration plugin, query filtered. Oh god, why it's taking mutable access to the world? That's interesting. A string input. I mean, yeah, we could try that. Let's just go with the resource for now, sure. The thing is, I do need a more configurable thing because I want to allow the user to do some stuff that I'm gonna keep as a surprise for now. But yeah, let's go step by step. Let's try that. Why not? So let's have a configuration, right? And by the way, there is a warning here in use result. In use, why this could fail though? Let's just unwrap it for now. Is there any other warnings that we have to? Okay, let's remove this junk. Whoops, let's remove this stuff. And let's remove this. And there we go. All right, so let's add that resource now. So we have a configuration and we're gonna add, probably import this guy. And there we go. And inspector options. Why this is having a problem? Not sure what the heck is wrong with that. Cargo B. Well, use Bevy Inspector, reflect inspector options, and now cargo B. Yeah, I guess that seems about right. Yep, it compiles, perfect. So now instead of name, we're just gonna have an string, right? So this string would be an expression. And now let's figure out how we can actually add that. So we init the resource. You need to register your type to display it. And then we resource inspector plugin. Okay, let's do that. We have to do it here. So where I have to do exactly? Maybe last, before the startup thing. I don't know, or maybe after the world inspector plugin. I don't know. Anyways, resource inspector plugin, import that, please. And yeah, I think we're good now. How do we use it now? I think we just this is a resource, so we could include it in our system. but the system needs to be updated now. So I need to figure out how to, but no, is there like a way to actually detect the configuration change? That's the real question now. Is there a way I could detect a configuration change? Yikes. Let's see, Bevy inspector. Let's go to the documentation of this maybe. Well, it's not giving a link here. So let's just look for it, docs. All right. And why this doc sucks? Let's see. Okay, there we go. Cool. So, what we want to check out. Maybe inspector options. Expand roughly to. Okay. Hold on. How do I create, or how do I detect, well, how do I create a system that runs when configuration resource change? Let's try, I guess. Let's see what's up. So configuration change, and yeah, there is a function called isChange apparently, and I guess we're gonna find out if it works. And I think we probably want to do that in the update method. Yeah, so we'll add systems, update, configuration changed. And let's actually try this out. So we do have right now a UI called configuration with an expression, and configuration changed with nothing. And if I change it, it actually works. Perfect. So now, whenever the configuration changes, we could rebuild the graph. Perfection. All right, so how are we gonna do that now? Good question. So I think we're gonna have like a resource graphs to store our graphs, probably. So struct graph derive resource. So let's call it graphs, okay? And it's gonna be graphs vec graph. And there we go. Now, how we're gonna do this? I think mutable graphs res mute graphs. Yep, exactly. And now, how we're gonna do this? Oh, what about the mesh handles though? Can we actually reuse a mesh handle? I don't think. Actually, when you drop it, it's just gone. But actually we are. No, we're not dropping it because it's being used by the PPR bundle. Yikes, I see, that makes sense. Okay. Okay. So we have a graph object, but also another entity. So everything have its own. Yeah, okay, fine. So we could have like entity maybe. So graph and an entity, I guess. Does that make sense? And then now, let's just say we have graphs is equal to vector new, right? And then we're basically gonna add that graph there. Push graph. I'm not sure. Let's make this mutable. Or it doesn't really have to be. Fine, just make it mutable, I don't care. And then we push it there, and we also need the graph entities. Well, I see. Oh boy. Well, we do actually have access right now to the resource, actually. So we could maybe push, no? Yeah, we could say dot graphs. So this is the graphs resource. Dot graphs, and then we could hopefully push a new graph. Okay, perfect. So let's actually put this, get this from here and actually put it here. So here we have the graph, I don't know, entity. Now the graphs dot push graph with the graph entity. Oh, dot ID. And I think that's basically it. Push graph and graph entity ID. I mean, I could make that graph as a component too, but whatever. So I think every time the configuration change, for now, let's just maybe remove everything, or no, not really. Can we have a vector of strings here? That would be amazing. Expressions. Does that work? Oops, configuration.expressions. All right. Does that work? Oopsies. What happened? Oh, we do not have a resource at this point yet, so that makes total sense. Alrighty. So we have to create it here, apparently, so let's actually do that. Let graphs. Well, let's actually say let graphs is equal to vec graph entity, and then we're gonna add the resource, insert resource graphs. Perfect. And yeah, let's see now. And there we go. And it is a list. Perfection. But it's kind of sucks, no? Yeah, I mean, it's not the best, but it works, right? So that's fine for now. Amazing. So now we could actually work with that. Perfect. So what we're gonna do there basically, where's the changed? There we go, here. So what we're gonna do is, we have the configuration and we need the resource graphs, yeah. So graphs is resource mute. So this is like the graphs resource. Perfect. Now what we're gonna do is basically we're gonna update the existing graphs, and if there's any new expression, we're gonna create a new graph. So that's essentially what we're gonna do here. No. No. So we're gonna have graph and, well, actually first of all expression. Then graph entity exactly. Kinda. Let's just remove these for now for a second. And here what we got, cannot mutate immutable variable graph resource. Cannot mutate immutable variable graphs resource. Oh yeah, we're gonna make it mutable. So we're zipping the expressions and then the graph resource. And the zip should basically stop when both ends, I think, right? If either iterator returns none, next from the zip it will return none. If the zip iterator is no more to return the yeah, I think that's probably what's gonna happen there, so that's good enough. Alright, so now we got the actual expression, we got the graph, and we got the entity, apparently, which is amazing. Do we actually need the entity though? What we really need exactly? Yeah, we need the entity so we can modify the mesh handle. Can we actually modify the mesh handle directly? Let's see. I don't think so. We just have to create a new mesh, I think. Probably. Can I reuse a mesh handle? No, it didn't understand what I mean. No, that's not what I meant. Anyways, whatever. We're just gonna do it the way we know how to do it. So I'm gonna change the mesh component, isn't it? Mesh. Handle mesh. Alright, meshes, that's all I'm gonna need for now. So let's go to, where's the configuration change system? Oh my god. There we go. That's a lot of stuff. Okay. Okay, let's see what we got here now. So we're not storing the context apparently. Now this system wouldn't run in parallel anyways. Okay, honestly I'd rather have the graph as a component. So we could like update each separately, I guess. Though we do gonna access the resource configurator. So no, it's not gonna be parallel anyway, I think. Yeah, probably not. So it's fine anyways, whichever. So now what? We wanna parse the expression, but we are not storing the context though. I mean, we could just create one new context, but why do that, you know? Or nah, actually let's just reuse one context really. I mean, we're gonna be processing them, at least for now, not in parallel. And but what is that context exactly? It's a hash map context. Perfect. And so we're gonna add this here. Fill the struct fields, and now we can access it. Oh boy, here. So we're gonna build the operator tree. We're gonna reparse the expression, and then graph update. Oh, can I just say that? Graph update. Expression with the context. And then meshes.set. No. We're gonna add like a new mesh basically. So meshes.add graph.mesh. And then we're gonna say meshes, well, not meshes really. How are we gonna do that? Yeah, we have the entity, but how we can get it mutably though? I think we need the commands. I see, my bad. Let's get the commands please. Mutable commands. Alrighty. Now commands get mute, I think, or get entity, yeah. And so we're gonna pass in the entity. Then we're gonna try to insert component, which is gonna be just like mesh handle. Insert the mesh. So just gonna replace the mesh, nothing else for now. I think that should work. Found mutable mesh. Huh. Interesting. Just say dot copied or clone. And I think that's it. Cannot borrow as mutable more than once at a time. Huh. Oh. Oh. Can I get the context here? But no, it can't. I mean, I see why that would be the case. Well, I could do something interesting, which is std memtake. And then it would basically replace it with an empty hash map, and an empty hash map doesn't really allocate, I think. Does that work? Let mutable context. And then finally after that, we wanna assign it back. Or honestly, yeah, just say really as context equal context. Yeah, that's basically it. Perfect. And I think we're good now. But this would only update the existing graphs. But let's just try this first. Though, yeah, we're gonna have a little problem. Hold on. We're gonna have a little problem, which is that the expression currently, it doesn't have to be valid at this point yet. So we gotta make sure to handle the errors how we need to handle errors. So for now, instead of in wrap in here, we need to say if let okay expression is equal to that, then we want to do our thing. We want to update the thing. So update the mesh with the new expression, then add a new built mesh from the expression and so on. And yeah, I think we're good. The other thing that could happen though is in the eval, so probably in the update function here, these could potentially fail, especially the eval number with context. The evaluation could fail too. For example, they couldn't find some string, like for example when the user type in sign, it would start with S and it would be changed and it would try to evaluate it, which gonna suck. So we have to account for that basically. So then what this gives an eval expression result. Okay, let's see what this result is here, please. I'm gonna comment this out for a sec. And let's see this result, what its type is. So it's a result F64 eval XPR error. Okay. Result F64 eval XPR error. And so, oh, sorry, not F64 here. We're just gonna have nothing. It's gonna return nothing if success. Okay, and here we can say like this, right? And so right now we could actually use this however we want. So vertex.y is equal to basically that. Perfect. Not sure why this could fail, but anyways. So I think that's basically it. Eval number with context. Now we're gonna go back into this update function, and if this is okay, then we're good. Then we have to update the new mesh. And I think that's basically it. We still have to program the new graphs when a new expression is added, but let's first of all try this one and see if it actually works first of all. And oh boy, what the heck is going on here? Oh man. What was that error? Bruh. Linking with Rust LD failed. What the heck? Why? How the heck am I supposed to read this? Maybe I should just clean out and do a new build. Oh my god, that's gonna suck so bad. Because I'll have to wait like 10 minutes or something like that, or even more. Let me try first of all to just restart the editor. If not, we're gonna probably have to clean out the build and hopefully try again. If it doesn't work, then oh man. Yep, it doesn't work. Please stop it. How do I stop this? I can't. Alright, fine. So let me think. Could it be that we have like some conflicting stuff going on here? Symbols, like conflicting symbols or something? I mean, let's just try and see what AI would say to this. I don't think it would help, like for real. I really do not think it would help with this. Oh boy. How the heck am I supposed to copy this whole thing? Oh man, no. No way. You know what? I don't think we have an option. Let's just remove this target and like cargo clean maybe. Never tried cargo clean before. And cargo build. Oh my god. Now we have to rebuild the whole thing in release mode. That's gonna take a freaking while. Meanwhile, I could take a break for now. Hey, I'm back. Alright, welcome to the live stream. Shambles, have you tried Aced? I'm early into learning Rust and wanted to additionally challenge myself by creating simple GUI apps. Yeah, I've tried Iced. I did have a good experience with that actually. That was nice. Though I do think maybe it's a bit still probably not ready for production yet. But yeah. But it was probably one of the best GUI only framework I've tried so far. Though documentation is a bit like in tutorials aren't really, there's not that much resource about it. I mean, it's still early on basically, so yeah. Now the problem is if we recompile this whole crap and then it doesn't work either. Oh my god. That's gonna suck so bad. If that doesn't work, then we'll probably have to maybe remove this, whatever that is, or this is. Maybe could be the problem. And I'm not sure why. Oh yeah, documentation is not great. Any recommendation for other GUI libraries? I've heard of Bevy, but never tried. There's a GUI, like the most popular one currently with Rust that is, that you could easily, get a GUI up and running is eGUI. It's not the best GUI library. I mean, it's retained mode. I'm sorry, it's not in retained mode. It's immediate mode, meaning that it actually re-renders the whole GUI every frame. But it works fine. It's the most popular currently. I'm not sure about any other ones that are good, at least for now. There's just a GUI and Iced. These are the ones that I know of. There is some other ones, but I never tried them. Bevy also have its own UI, which is kind of CSS thingies, which I'm not a fan of. But yeah, it probably works. I've seen some people really make some nice UIs with Bevy too, with Bevy UI. So that works too. But not my cup of tea, I guess. Yeah, eGUI, yeah, it's the most popular one. It's the one that is used by most people using Rust, especially in game engines and like games and so on, and especially for debug tools. For example, in this application that I'm creating here, I'm actually using eGUI. So yeah. Oh boy, this is gonna take a while to compile. Hopefully at least it works after all this wait. I have no clue why the heck it suddenly just gave me that weird linking error. And I'm not looking to make anything crazy at the moment, since I'm still new to Rust in general. Yeah, what you're trying to, like, if you tell me what you're trying to make with it. But if you're just wanting to, oh, I'm early into learning Rust and wanted to show my challenge. Yeah, eGUI would really work out for you. Though it kind of sucks to some degree with, like, you're gonna have a lot of callbacks, and that's like most Rust based GUIs would be like that. And just because of the borrowing error, like borrow checker and stuff, it's kind of forced that they have such a way of doing things. Kind of sucks, like you're just gonna have a lot of nested closures, but I don't think it's avoidable. Ice though did, I don't really remember, but I think Ice isn't that bad in that aspect. I remember. Ice is very similar to how, let's say, the newer Android UI works. like Jetpack, Android Jetpack, which is honestly very, very good. Android Jetpack, I really love it with Kotlin. It's just like the best UI framework I've ever used so far. It's very, very, very good. Yeah, EGUA does require a lot of callbacks and ISU traits for custom components. Yeah, pretty much. I do want to also support, let's say, equations. But of course the eval here wouldn't be able to do that. But one solution could, if in fact the cosmic DE is iced. Oh, I see. Cosmic DE. What DE stands for? I don't actually remember. But yeah, I'd like to include desktop environment. Yeah, I'd like to include equations too into this calculator, graph calculator. But of course this eval RS doesn't include that because it's not really a full-fledged, you know, computer algebra system. It's just like an evaluator, so we cannot do things like, you know, calculating derivative expressions and so on, and like equations, simplifying expressions and stuff like that. Actually it does do simplifying expressions, but probably not that advanced. But all right, great. So I actually recompiled it and that linking error somehow have been gone, which is great. Now the real question is, would this actually work? Okay, look at that. So right now this is x. If I say x times x, there we go. Perfect. Let's actually make this a bit bigger. I wonder if I can make these text boxes bigger without having to create a custom UI. But yeah, probably have to create my own custom UI for this really. So that's pretty cool. X times x to the power of 4, 5, 6. Let's say maybe that. There we go. X to the power 5, 4, 3, 2. Okay, sine of x. Or cosine of x. Oh, what? Maybe I haven't included that, or what? But like I could say 10, for example. I was just about to ask if sine works. Well, actually somehow sine works, but cosine doesn't, which is interesting. But this is very strange, like for real, dude. What the heck? It's very small field, unfortunately. Yeah, here we go. Cosine actually works. But I'd like to do something very, very interesting with this. But hold on, we still haven't implemented multiple expressions. Oh, unfortunate, I see. Well, let's actually implement now multiple expressions, multiple graphs, and let me close that damn window. All right, let's see what we got. And why the heck do I have an error here? Let's leave cargo check to do his job. All right, so what we need to do next is basically to iterate through the rest of the graphs that we have that aren't included. So the rest of the expressions essentially. So how are we gonna do that? Well, Well. Let's see if the AI would pick up on that. And no, that sucks. Generate the new graphs if needed. Exactly, that's exactly what I want to do. So let's see if the AI have done this correctly. For expression in configuration expressions, either skip, and then it skipped the graph resources, graphs.length. Perfect. And then if okay, expression eval xpr, blah blah, let graph new 64 dy splat. If graph updates, blah blah. Yeah, that's pretty good. Pretty good. Though we could do the updates for the whole thing at once, actually. Anyways, let's just go with this for now. Fine. Cargo R. And now we should have multiple stuff working. Multiple graphs. If I didn't forget anything, of course. Oh, by the way, what about the material here? It doesn't seem to add the material, which is interesting. So we're probably gonna need that though. Yeah. All right, let's see what we got here. Cargo check, please stop. Or, you know, just let it do its job. Otherwise, we're gonna have a broken editor. I mean, we're having a broken editor right now. Oh boy, it's gonna take forever again. Thank you, Rust LLD linker. Oh my. So I'm gonna add something very interesting. The only problem with that something that is interesting that I have in mind is that we'll have to freaking make a new mesh every single frame, which may actually suck in performance. This probably would be fine with a handful of expressions, but well. Anyways, let's see what we got. So we got this, and there we go. We have two graphs right now. Let's say that. There we go. And I don't know, x to the power 3, I guess. There we go. Oh, what the heck? Why not all of them show up properly when it's the wrong face? That's strange. I'm not sure what the heck is happening here. Probably maybe the calling or something like that is not done right when it's the wrong face. I don't know what the heck is happening there. But yeah, it seems to be working. Amazing. Alright, so what do I want next? Like we could add just how much whichever expressions we want. The sign of x works. Yeah, it does seem to work, I guess. There we go. But something is very strange there, honestly. With the blending, I guess, of transparent objects, maybe? I'm not sure. That sucks. But yeah. That's pretty cool stuff. All right, so what's the next thing that I want to add? Okay. Let's me kind of figure this out. You know what? What if I actually update all these graphs without checking, like every time, doesn't matter if it's changed or not. Every frame, how the performance would be like? That's my question now. So I think I am updating right now all the expressions every single frame. I mean, it seems to be fine so far. And here is the magic that I want to add. And I'm not sure what the heck is wrong with this. Anyways, here's the magic. What happens where? Yeah, so here in configuration changed, what we're gonna say is mutable. Let's see what I'm gonna do here. Oh, maybe I know what's wrong with that one, by the way. Hold on. Maybe I know what's wrong with that, possibly. Maybe I should make sure to do this. To make the material. I should probably just store, well, yeah, let's just store, I guess, the material for now. So configure, not that, here, yeah. Let's just store the material, please. Handle, standard material, I guess. This mouse scroll, damn. Yeah, I have to change it. Honestly, I have to change my mouse. Programming AFAQ, think like, welcome to live stream. Okay, let's quick fix, fill struct fields. Yeah, thank you for a reminder. I really have to change this mouse. It sucks. Anyways, commands, material. Oh, I called it a mat. Interesting. Well, no, I want the white material here. Use of moved value. I see, that makes sense. So let's clone it, and now I think I could probably do this. And I'm probably gonna need to do something similar to the material. Maybe, or maybe not. Let's see if how that goes. Yeah, let's see how that goes. How I'm gonna do this. So here when we generate new meshes, we wanna make sure to have the material set is equal to, what did I call it again? Oh, I haven't got it yet. Okay. So it should be called configuration. Well, not configuration. Where the heck am I storing that, dude? Oh, graphs resource. Okay. Dot material. But of course I gotta. Oh. What the heck? And I have to clone this. And of course this wouldn't clone the actual material, it would just clone the handle to it. Let's see if that fixes that problem. Alrighty. X to the power of 2. X to the power of 3. Is that fixed? I mean, It is, but there is some artifacts there for some reason. Not sure why. But anyways, that's good enough, I guess. What's next? Yeah, let's do something interesting here now. So before we do this stuff, before we update, let's actually say, actually context, yeah, context dot set. Well, I'm gonna need, oh boy, the AI already realized what I'm gonna do here. Anyways, well, not res mu, just res. Why the heck would I want to change time? But hold on, does this actually give me that or no? Maybe elapsed? I'm not sure. I mean, let's try it out, I guess. Well, just T. And let's see if this works out as expected. Okay. Now if I say, let's say sine x plus t, and there we go. There we go. Yeah, I really have to make my custom UI, honestly, this sucks. Big. Cosine of x times, well, plus t, I guess, times 5. There we go. That's pretty cool. Sick. And of course a 3D graph is also a 2D graph. And in fact we do have lighting. Oh, I think the artifact is probably from the lighting though. I should either disable the lighting completely or make use of directional light. Yeah. Okay, how do I disable lighting? Material handle. Yep, perfect. Now maybe that would fix it. That would fix those glitches that shows up. Oh my, that looks cool. Now let's try that out again. Let's add another one. Let's say that that's cosine. And yeah, we don't have that problem anymore. Perfect. We don't have that problem anymore. So it was just a light that was problematic. So then that means I don't really need the light. I just need my camera, my graph mesh. What the heck is going on here? Well, let's actually remove this stuff from here, I think. Yeah. That view graph. Insert resource. Yep, pretty much, I think. But hold on. Yeah, exactly. So let's remove this stuff. Graph entity, we don't need it. The only thing that I think we need here, we don't need the graph either, nor the graph mesh, nor this expression stuff. The only thing is the context and the material. Yeah, the other stuff could be would be dynamic, which is cool. And so remove this mutable. We don't need the meshes here. And that's basically it. Let's just real quick try this out just to make sure I haven't ruined anything yet. Curious what attracted you to learning Rust, and could you recommend any project that help you learn? Honestly, good question. I don't remember. But I was certainly not a fan of C++. That was a thing. And I was like, I'm also just like I'm passionate about learning and teaching, you know? So I constantly learn new stuff, new languages, new technologies, and new stuff. And Rust was one of them, and I loved it. Like, it was one of the things I really, really loved. And yeah, it's my favorite language right now. I can't really remember exactly what attracted me to it. It was like maybe 3 years ago or something. But yeah, let me see if this works real quick. And for what projects I would recommend to help you learn? Man, I don't really have any specifics. But here's some resource I would recommend, I guess, for starting. Of course, the Rust book. This one is very popular, of course. There we go, the Rust book. This is the one you should start with. And another thing would be some YouTube channel that I personally at least found very useful. Especially in those intermediate to advanced topics in Rust. I don't remember what is it called. I don't remember what the language was. Sorry, the channel was called. Well. Yeah, there we go. This guy right here, John. Come on. Can't copy his name. But yeah, this guy is very... Let me actually type it out in the chat. I mean, at least for me, I found him very useful. He also do streams, just like me, so... Other than that, I don't know. So at least those were the resources that I really remember were helpful. But yeah, other than that, I would just like make a lot of projects, you know, and just work with the language really. So yeah. And one of the other things is you have to learn how to deal with the compiler, because the compiler is like your best teacher in Rust. So yeah. Other than that, okay, so what we want now to do, I forgot completely. Well, one thing that I would like to actually do though is you see that right now it actually like switches the graph immediately. Can we maybe tween it? That would be amazing. And this is annoying me. Let me try to grab the VS Code back. Oh yeah, that's one thing. The second thing is the UI. I want to make my own custom UI. You're welcome, Chambles. I want to make my own custom UI. That's the first thing. And second thing is another feature that I would like to do, but let's keep that as a surprise too. All of this is inspired by application by a graphic calculator called Desmos. So yeah. Well, most of this. Desmos though is like a 2D graphic calculator. This one would be 3D, so yeah. Anyways, let's wait for the IDE to index stuff. And let's remove this. Alrighty. Is it fixed now? Yeah, I think it is fixed. Perfect. Perfect. Though one thing that is also annoying me, 3ds mode. One thing that is also annoying me is the fact that the graphs doesn't get saved between sessions, which like every time I have to test, I have to retype everything. Maybe we could make use of another crate that I've seen while exploring, which I think Bevy persistence, I believe. I mean, we could like implement this ourselves, but there's no need if there is another crate that can help you with that. So cargo add Bevy dash persistent. I'm not sure. Cargo add Bevy dash persistent. Okay, so Bevy persistent prelude. Yeah, let's actually copy this. Oh. Use Bevy. Ooh. Okay, I see. Use Bevy persistent prelude. And then what we do, you need to find resource and need to implement serialize. Okay, we also need Surday apparently. Oh boy, we have to separate the expressions probably from, actually no, we already have those, yeah, so that's fine. Though I'm not sure how it's like, if it's gonna be fine with these other traits. Whoops. Let's see. I've never tried it. Derive inspector options, comma, serialize, comma, deserialize. That's a lot of stuff. Let's make sure this at least still compiles though. And no search format are selected. Okay. Dash dash features all, I guess. I'm not sure which one I'd like to use now. But later on we could change that. Alright, what else? Jump creation. Where is my resource? Where we're doing that? Oh, really? Configuration. Oh. Add plugins. Huh. So we're not inserting it manually. So how are we gonna do this then? Commands.insert resource. Oh boy. Oh, never mind. I think we just say persistent and then do that. Okay, gotcha. Makes sense. So did I actually add this now or not yet? No, I haven't yet. Okay, cool. All right, let's go down here, for example, maybe. And let's just say this config dir, and let's actually copy this too. Let's see what we got here. And what is this exactly? Huh. This basically needs a directory. But there's no dirs here. That's strange. Meh. No, can we just like give it like a regular directory, please? And instead of key bindings, we want our configuration here. Name configuration toml for now. And then here we're just gonna say, I don't know, configuration.toml maybe. And then here default key bindings. Well, default configuration, right? So build and stuff like that. Cool. Erase Surday privacy not satisfied. What? I'm pretty sure I did add that. Oh. Import Surday and import Surday deserialize. Would that work now? Yeah, seems about right now, which is great. Default. Now let's try this out. Let's see if it would actually work. But hold on, how are we gonna load it though? Well, good question. You can access it like this. But let's just see what's gonna happen anyways now. Okay, and then you do key binding persist, expect, fail to save new key bindings. Huh. And right now I can cook eggs on my computer, on my CPU. Oh boy, this seems to be taking quite a long time. I feel like probably have to do with this thing right here. That's why maybe it's recompiled the whole crap. Problem is, if I remove it, it may recompile everything. Oh man. Well, I guess break time. Break the code here. Break until the persistence is fixed. Break until the code, the next section, the code below is complete, compiled. Alright. Back. Seems the code have compiled now, which is nice. Okay, let's try to add some expressions here and see. So let's say that and that, for example. And stop. Did it add anything here? I mean, yeah, it did make expressions is equal to that, but it didn't save those stuff. Which also makes sense because we haven't called this persist function. So instead of saying like, we have to say persistent. Alright, cool. Let's go to configuration. There we go. Let's actually say rest persistent configuration, I think. And then hopefully at the end of it all, you could like try to persist this. But no, this is gonna suck. Well, if configuration changed though. Yeah, exactly. If it is changed. I'm not sure how much that would slow it down, but let's see. Hopefully not by much, at least. And so let's see. So we have our configuration terminal here, and now oh, what? It actually doesn't work anymore. Huh. Neither the configuration thing. Interesting. Well, let's go back, please. That's weird. That's weird. What if I actually took that as a separate resource and then I called persist? Would that help by any chance? Now, if configuration is changed, then persist.save, well, .persist. Now, would that actually work? I guess let's find out. Hopefully, yeah, but let's see. X, well, at least the graphing works, but the actual persistence doesn't really seem to work, and I'm not sure why. Yeah, apparently. Not sure why. Well, honestly, meh, let's not do it that right now, I guess. It's fine for now. Okay, so I think at this point we didn't have that, right? Didn't have that persistent crap. Yep, no. Well, I wanted that to work, but apparently it doesn't. So let's just actually add by default, you know, you're gonna have some expressions inserted into there. So like, okay, so can I do this and then like implement default, and then I can give it some expressions here essentially. So like, for example, cosine of what is it called, x times, let's say 5 or like 6 actually, plus t, and then what else, and then maybe let's scale it down a bit, like, I don't know, 0.5, not sure. And yeah, now let's make another one for sine wave, let's say, And there we go. Now this should start there, which would be useful for debugging, so I don't have to, every time we debug this, we have to type in the expressions for now. There we go. Perfect. Perfect, perfect, perfect. Now I probably should actually remake this UI, honestly, because this kind of sucks. Though I wonder if we can actually fix it without like remaking the whole thing. Good question, I don't know. Well, how are we configuring it though? Like configuration. Oh, I think just through the macro probably. Yeah, probably. Probably just through the macro. Well, honestly, let's forget about that for now. Let me do something else that I'd like to do, which is tweening. Because right now when you actually change the function, like it just, you know, changes to that new function immediately, which really sucks. Right? So let me try to make it not do that, basically. So how we could do that? So maybe we probably need update function here, and then we probably gonna need the delta time. So time dot delta time, delta seconds, basically. And now let's go to this update function, and we're gonna get the delta time here, f32. Now how we could do this? I mean, we do have right now the original, and this is basically the target value, right? So target is equal to that. Whoopsies. Oh boy, that sucks. Let target is equal to this. And now we want to lerp this. Whoops. Come on, lerp. Vertex.y. Well, I think there's probably a better way to do that though. There we go. Let's try this. But what's the problem here? Provide the argument in line 172. Yes. Delta time. Well, basically time dot delta seconds, right? Let's try that out and see if it works as I expect it to. That would be amazing if it works. Let's see. Alright. Let's say, for example, instead of 0.5, let's say 0. Oh boy, that is amazing. You see? So it lerps to the new function. Oh boy, that looks super amazing. Okay. But that's super slow, which kind of sucks. Honestly, maybe I'm not gonna take into account the delta time. I'm not sure. But basically, I think what's happening there, it's probably like that equation of POW-F and so on. It's probably making it so that the speed of the lerping is delta time. What if I just say delta time? Or just 0.5, I don't know. What if I said just that? Let's see what's gonna happen. Because I do want to, for the speed to be the same like basically I want the duration of the whole animation to be the actual same. So let me do something here. Let lerp duration, right? And let's see what the AI would actually do. It seems to be doing that. I don't think that's correct, honestly, but if it works, I guess. Now let's try 5. That's cool. 1. Yep, but 1 second is too much. Let's say maybe 0.1 or something like that. Not too slow, but not very rough, you know. There we go. That's cool. Love that. Absolutely love that. That is very satisfying. Look at that. That's pretty sick. Though for the subdivisions, we could also make them configurable. Could make the subdivisions configurable. How are we gonna do that? Let's see. So in the configuration, where is it? Oh boy. Oh well. No. Actually, better not. Yeah, we have to reconstruct that whole graph object and so on. Nah. Never mind. But maybe we could just like. Where is the subdivisions first? What we're setting it to? 64 apparently. What if we go with 128? Would it still be performance enough? No, I do feel like it's a bit slower now. Yeah, for real. Nah. 64 is fine. Alright, I think I'm probably gonna stop the video maybe here, honestly. Yeah. Let me know your ideas for this calculator. But yeah, I'm gonna put this into GitHub. If you have any ideas to extend it even more and so on, let me know. Or you could just contribute yourself. You're welcome. So let me actually put it before I forget, because I'm probably gonna I'm just gonna stage all these changes, really nothing crazy. And in fact, let's remove maybe nah, just keep it. And let's just say, I don't know, first stream commit. And thanks for the advice. I try to stop by the streams when I can. Take care. Goodbye, Chambles. Thank you for coming in. Commit. Sync changes. Okay. And let me give you the link to this. Hi on caffeine. All right. So. What is it called? Graphing calculator, there we go. All right, this is the link in the chat. And that was it, guys, for the stream. Thank you for watching. Thanks for Robert, Loop Luminary, of course, the person of watch, Hads, and Woji Gearing. And who else? Chambles, Theo Paris too. Thank you all for tuning in, and see you later. Goodbye, everyone.